Okay, hi everybody, this is the last unit in higher physics electricity, and we're doing a wee bit of revision to start with, revision of circuits. And we're going to use the PhET website, PhET, if you just Google that. Or you can get an app for your phone. There's an app for iOS and Android, and you can use all these simulations. We're going to use one called Circuit Construction Kit DC. Once you've found it, just open it up, and once you do, you'll be able to build all your series and parallel circuits and revise voltage, current and resistance from last year. So click on the lab, and then you'll get a blank canvas where you can drag your components out. There's batteries, there's bulbs, there's resistors and switches. I'm going to start off just by building a very simple series circuit, battery, some wires, and a single resistor just to check out Ohm's law. Remember Ohm's law? Blimey, that was a while ago. So there's my simple circuit, and once I've got it all wired up, we can drag out some meters and start measuring current and voltage. Right, there we go. You can see the charges flowing around the circuit. You can change the battery to whatever voltage you like. Let's go for 12 volts, that's the old favourite. And let's increase the size of that single resistor up to 20 ohms. Now you can go up to the right hand side there and click values, and that will show you the value of the battery voltage and the resistors. And then we'll drag out a voltmeter, and because we've only got a single resistor there, then it should be receiving the full 12 volts. An ammeter will measure the current. And remember, it's Ohm's law, so I equals V over R. 12 over 20 is 0.6. And it doesn't matter where you measure that 0.6. It's the same at all points in a series circuit. Current's the same all the way around. Nice and easy. Now you could show the symbols. It uses American symbols for resistors, so I don't really like that. I would just go for the pictures. So get rid of that by clicking the wee circle in the bottom right, and this time I'm going to build a series circuit but with two resistors in it. Now remember, we can change those resistors to whatever we like, and we can change the battery voltage to whatever we like as well. If you want to get rid of a component, you just click on it and click the little bin symbol. If you want to break into a circuit, just click the join, and a little pair of scissors will come up and you can open it. But there's our series circuit, and again you can see the charge flowing. And let's change the resistor values. Right, let's see, let's make this one, will we go 20 again? No, let's go 15. Let's make that one 15 ohms, and let's make this one 15 ohms as well, so they're both the same. And we'll make our battery voltage 12 volts. And let's show the values on the diagram. There we go. So we can see everything. Now you should remember from last year that to add resistors in series, you just add them. So the total resistance there is 30 ohms. And if we bring an ammeter out, the current, I equals V over R. So it should be 12 over 30, which is 0.4. And again, it doesn't matter where you measure that. The current's the same all the way around. Total resistance of the circuit is 30, so the total current flowing is 0.4. But these two resistors are sharing that voltage, so how much voltage will each one get? Well, because they're both the same, that resistor gets 6 volts, and that resistor gets 6 volts. So this is a really easy way to build some simple circuits and just check your knowledge of voltage, current and resistance. Let's change one of them. Let's make that 20, and let's make that 10. So these two resistors are different. The total resistance is still 30, so the total current should still be 0.4. Yes it is, yes it is, yes it is, yes it is, yes it is. But what about the voltage that each resistor gets? The one on the left is twice as big. So let's measure it. Connect your voltmeter across it, and that resistor gets 8 volts. And that one only gets 4 volts. And again, we could use Ohm's law to check that that is correct. So V equals IR. You could make these resistors any value you like and do some quite complex calculations. Let's make the 23 and 8 ohms. What current will we get? Well, there you go. You could do the Ohm's law calculation to work that out. And the same to work out both those voltages. So the bigger the resistor, the bigger the share of the voltage it gets. That's nice. Series circuit. Now if we can do series circuits, we can of course do parallel circuits as well. So to make this into a parallel circuit, there's our single resistor. Let's make it 20 again. And let's drag another one down and put it in parallel, which means adding another path. And let's change that one to 20 ohms as well. 2 resistors in parallel. Hopefully you remember from last year how to add resistors in parallel. Or maybe you remember the wee trick. The wee trick is if you've got 2 resistors the same in parallel, the total is half of one of them. Now before we start worrying about the current then, let's bring our voltmeter down. We'll measure current in a wee minute, but let's bring a voltmeter down, because if you've got 2 resistors in parallel, then they are both directly connected to the power supply, to the battery, so they both get the full 12 volts. Let's check that. So that one gets 12 and that one gets 12. They're both in their own individual paths, so they have a direct connection to the battery. Now if we put the voltmeter away then and think about the current for a wee minute, remember if we only had one resistor, one 20 ohm resistor, let's just get rid of one just now, put it in the bin. Then what current did we get? Well, I equals V over R, so 12 over 20 is 0.6. 0.6 everywhere. If we put another resistor in, and we make that 20 ohms as well, and because it's in its own little path, it will get 0.6 amps as well. So therefore the total coming out of the battery must be 1.2 amps. 1.2, 1.2. But remember it's going to split here. 0.6 will go through that resistor. 0.6 will go through that resistor. Then it'll join up again, we get 1.2 amps. Now if the total current is 1.2 amps, then the total resistance of these 2 resistors must be 10 ohms. And remember you've got your resistors in parallel equation to help you calculate the total resistance of resistors in parallel. Now at higher physics we have to get slightly more complex. It's the same rules, it's still Ohm's law and adding resistors in series in parallel, but this time you'll probably see some circuits that have got a mixture of series and parallel resistors. So let me just try and build one here. Now you can spend as much time as you like messing about with these wee circuits, but I'm going to put this together and I'm going to have, in parallel, I'm going to change these and show my values. I want to have 60 in parallel with 30, and then I want that in series with a 20. So let's show you all that. Show the values. Still a 12 volt battery, but we've got a 60 in parallel with 30, and then in series with a 20 ohm. Now, what we want to work out is what's the total resistance of the circuit, what's the total current that comes out the battery, and then how much current and how much voltage will each resistor get. So, let's tidy it up a wee bit. First thing you would do then is work out the total resistance of the 2 resistors in parallel. That works out to be 20 ohms, if you work that out. Then 20 in series with 20 gives you a total of 40. And then if you work out the current, I equals V over R, 12 over 40, gives you 0.3 amps. So 0.3 amps is the total current that comes out the battery. Now how much is going to go through the parallel bit? Well, the bottom resistor is half the size of the top one, so it will get twice as much current. So 0.2 through the bottom, 0.1 up the way. And 0.3 will go through the 20 ohm resistor. So this is an excellent way just to check your basic knowledge of voltage, current and resistance using Ohm's law and your resistor equations to do some circuit analysis. What about the voltage then that each of these resistors will get? Remember the two parallel resistors, the total of the two of them is 20 ohms. So if we've got 20 ohms in series with 20 ohms, if I bring my voltmeter down, then there should be 6 volts across the parallel bit. Let's just check this one first. That should be 6 volts, because the total of the parallel bit is also 20 ohms. So the 30 ohm resistor should get 6 volts, and the 60 ohm should get 6 volts as well. Resistors in parallel always get the same voltage. That's it then. Download the app. Tell your pals to download the app as well. Have a little resistor party. Get some crisps and pop. Design your own wee circuits. Send them to your friends. And see if you can work out voltage, current and resistance. We will be using this in the next couple of weeks as well. So see you in the next one.